once again, thank you everybody for joining, and sorry about the little bit of delay. But yeah, if you're new to this meeting, we run a Partner Tech Connect every month where we do special sessions on first Tuesdays of the month and open Q&A hour every second Friday of the month. So this month's topic for the session is Cosmos DB Cassandra API and MI migrations. And like I said, my colleague Theo has especially recorded this. So let's start, and please feel free to put your questions in the chat.
The Cassandra API and MI migrations. So in terms of an agenda, I'm going to set some context on Apache Cassandra to begin with very briefly. I'll then talk about Cassandra API and Managed Instance and choosing between these offerings. And then for most of the session, I'm going to talk about the migration approaches for these offerings. So in terms of Cassandra, what are the cool bits? So what are the not so cool bits? Of course, it's the backbone of Facebook, which is where it started, and Netflix. And the benefits of the platform are obvious. It's distributed, linear scale, write optimized, fast reads. It's very high performance system. And it has a pretty short learning curve for app developers as well. What's not so cool is it's pretty complex to maintain. This is really the trouble that most customers and users of Cassandra have. And that obviously makes it a pretty good candidate for an API in Cosmos DB. And of course, what is Cosmos DB? It's a fully managed NoSQL database platform with turnkey global distribution. And of course, we have comprehensive SLAs across various performance dimensions. And so with Cassandra API, we surface the API as an interoperability layer. And if you're building an application that wants to talk to Cassandra, it need not know the difference between Cassandra and Cosmos DB. And you can use all of the open source tools that are out there, and they will connect and work pretty seamlessly. Of course, this does depend on the features that we support in the API. In the case of Cassandra, you definitely want to look at the documentation to find out and confirm whether or not we actually support the feature that's being used. We're adding feature compatibility all the time, and we're getting pretty close to being near compatible with everything. But it's not completely compatible. And of course, that, amongst other reasons, is why we've introduced a new offering in Cosmos DB called Azure Managed Instance for Apache Cassandra. And so in terms of choosing between these two things, it's really pretty straightforward. It's a spectrum of really control versus productivity. Managed Instance for Apache Cassandra is essentially open source Apache Cassandra running on virtual machine scale sets. Effectively, it uses the Cosmos DB control plane to do automation for deployments and for scaling and for patching and so on. But it effectively is an open source Apache Cassandra, so it's fully compliant, fully compatible. But the various things are automated, and the management is taken away from you to some degree. And another way to think about this is to use this analogy, which I like using, which is that if you think about it in terms of using a car, or if you need to use a car, you have a need of a car to travel somewhere. If you don't own a car, or you don't drive a car or have a driving license, or you can't afford to buy a car for whatever reason, then something like Uber is going to look attractive to you because it's relatively cheap if a car is what you need, and that would be the sort of Cassandra API equivalent, I suppose. But if you have a car and you already have a driving license and so on, you already incurred the expense or the investment for having a car, then maybe a manual shift or an auto shift is going to look more appealing to you. And this analogy kind of works as well because there is a kind of dividing line between the Cassandra API type offering and something like a manual shift or an auto shift or self-hosting Cassandra and managed instance, in the sense that you're still in control of driving the platform, both with self-hosting and with something like managed instance for Cassandra, whereas with Cassandra API, Microsoft is controlling the platform. You're really only thinking about the application level concerns. So that's really the way to think about these offerings and the difference between them. Over time, with Managed Instance, we are adding more features and more control, if you like. So you could think of that as turning it into more like a semi-auto shift. So you're pretty much managing almost everything. But to carry the analogy further with cars, there'll always be a few things, like with a semi-auto shift, the system still controls the clutch, and I guess the equivalent of that on the Cassandra side would be things like deployments, operating system patching, and scaling. Managed Instance will always be doing that, but we're going to add as many features as possible that give customer the maximum amount of control that we can still give them while still maintaining some kind of service that we can call a managed service. So that's it in terms of the context and choosing between these offerings. If you have questions about that, I'm sure we can answer them at the end, but I'll go on and talk about migrations now, which is going to be the bulk of what I'm talking about here. So if we look at Cassandra Managed Instance live migration first, really the recommended way of doing this is to configure what we call hybrid cluster. Because Managed Instance is effectively open source Apache Cassandra running on virtual machine scale sets, what we've enabled is this capability for setting up hybrid clusters. And the reason that we can do that is because we inject machines into a customer's virtual network, and so that allows them to have a self-hosted data center in their own Apache Cassandra cluster and have the managed instance data centers effectively join that Cassandra ring. And so I'm just going to talk a little bit about this with a short demo. Okay, so I have a resource group here where I have deployed an open source Apache Cassandra cluster, just a vanilla open source cluster with 3 nodes. And I also have this resource here. And what happens in Managed Instance for Apache Cassandra when you configure a hybrid cluster, what you're effectively doing is telling the system that any data centers that I deploy in Managed Instance for Apache Cassandra are going to join a cluster of this name. They're going to join the Cassandra ring of this name. And the reason this is possible is that when we deploy data centers, we only inject them into a virtual network. In this case, I've called that VNet Cloud VNet, and we expose the NICs, the network interface cards, and the IP addresses. And so there is bidirectional connectivity there as long as you have peered that VNet to another VNet that has access to your self-hosted cluster, whether it be on premises, through ExpressRoute, or in Azure or some other cloud environment. And that's it, really. That's how we allow a hybrid cluster. So when I go, one important thing to note here is that if I just go quickly back into my cluster resource here, the data center tab in the cluster resource will only show me information about managed data centers. So if I had multiple data centers that were deployed through Cassandra Managed Instance, I would see them all here, but I wouldn't see the data centers that were part of the cluster that were self-hosted. So for that, I would have to go onto one of the nodes, much like I have here, and run node status. And in this case, I have 2 data centers in my cluster, and I can see my self-hosted data center up here, data center 1, and then I also see that data center that you just saw, DC1, back here, that is hosted in Azure. So that's it. I just wanted to show a little bit about the configuration. And of course, when you have this set up, this is by far the most seamless way of doing migration, because you're using Apache Cassandra's native replication capability. Once your data center is part of the existing self-hosted Cassandra ring, then replication will happen, and everything will be in sync seamlessly, and then it's just a case of doing an application cutover. If you want to cut over to the new data center and decommission the old one, in some cases customers might want to just keep it there until they're happy with things, or maybe they want to use Azure as an extra capacity in times of peak load or things like that. So there's really options there. But if it's purely for migration, then if customer has the capability, if they have a cluster running on a version of Cassandra, version 3.11, or very close to that, of open source Apache Cassandra, they should really configure a hybrid cluster for migration. That's by far the most seamless way. So that is live migration using a hybrid cluster setup for Azure Managed Instance for Apache Cassandra. I do just want to mention quickly as well that although I didn't show how to configure a hybrid cluster, that is all pretty much straightforward, and we have that documented here in our docs, and there's also a YouTube video that accompanies that and walks through these instructions. They're pretty straightforward. It's the same as adding any data center to any existing Apache Cassandra cluster. Effectively, we've just opened up that capability. The key benefit to point out here is the fact that, of course, Managed Instance is a managed service for Apache Cassandra. It deploys Cassandra nodes in a data center to an existing VNet. We manage the nodes, we expose the NICs, the network addresses, and then we provide automation for deployment and scaling and so on. But effectively, outside of that, it is an open source Apache Cassandra data center running in the cloud. So it's pretty straightforward. Then once you have the networking set up, to connect that to an existing cluster that's running basically anywhere. And that's it for the hybrid cluster setup. Okay, so that was hybrid cluster setup. So for Cassandra API live migration, and this actually also applies to migrating to Cassandra Managed Instance as well, if you happen to be running a cluster that isn't compatible with the versions that we support, or in some way is locking that down. Maybe you're running a DataStax cluster or something else where you need to take another approach to live migration. The approach I'm about to talk about and show works with that as well. And of course, here when I'm talking about live migrations, I'm talking about like for like. So you're already running some flavor of Apache Cassandra on premises, and you need to migrate to one of these services. But in this case, this approach that I'm about to talk about will cover a wider number of use cases. I'm going to show it for Cassandra API, but as I said, it would also work for Cassandra Managed Instance. And the pattern, and this isn't a particularly new pattern, it's very popular. Many of you will already have know about it and will have applied it to other databases and from different sources and targets and so on, is if you imagine writing to an old database on a timeline, and typically you'll start with migrating the schema, and then you'll configure your application for dual write. So in other words, you'll change your application code to write to both source and to target. Typically to target will be asynchronous, and to source will be synchronous. So your application will be working as normal, but it will be writing to two targets, the source and the original database and the database that you want to migrate to. And then if necessary, it's not always necessary, you might need to migrate the historic data as well. Of course, if your data retention is quite low, in other words, data only remains hot or relevant for a short period of time, say a day or 2 days or a week or something like that, and then it just becomes aged and old and so on, then you could just leave the dual write process running for that period of time, and then once your aged data has become irrelevant in the old system, then you just cut the application over. But typically most applications will be keeping data for quite some time, so you'll need to do a historic data copy as well. And then at that point, either way, whether you've left the dual writes process running or whether you've done the historic data copy, once historic data is resolved one way or another, your databases should be in sync. You'll then go through a process of validation, and then you'll have your application cut over. And that's really the pattern that I'm going to be simulating in a little while. So I'm going to be using an open source tool that we've developed that we've called the Cassandra Proxy. It's a DualRight proxy. And the reason that we've developed that is, if I just go back to the slides here, the difficult part about live migrating with this approach is, of course, changing your application. And generally speaking, customers will not want to do this, especially if they're you are working with teams who are not app developers, or they don't really want to. Either way, they don't really want to change the code in the application. That's invasive, and maybe it involves hundreds or thousands of lines of code changes. So what we've done to make that more straightforward is develop a proxy where you can just install the proxy onto the source cluster itself, and then the proxy will route the requests from source to target. Sorry, it will route the requests both to the source database, your current database, and asynchronously to the target database, and all your application needs to do is change a port. What I'll also be showing for the historic data copy is another sample called Cassandra Migrator, which uses Apache Spark and the Cassandra Spark connector to do the historic data copy. You could also use this process for offline migrations as well. And this includes a validation routine as well, and also a way of retrying failed records also. So in terms of the DualRight proxy itself and the way that it's built, it uses an open source framework called Vertex, which is for reactive applications on the JVM, and for developing various things like proxies. What we have created is a piece of code that has a proxy class and a proxy client class. The proxy is responsible for message parsing and processing, and the proxy client will handle the node connections themselves and the wire protocol, including upgrading and downgrading where necessary. And there's also some utilities for handling credentials and decoding the Cassandra data stream for processing in the proxy. So it's just a little bit about how the proxy is built. It's an open source tool, so you can investigate that for yourself. We also expose some metrics in the tool. We're improving this all the time, and of course we welcome contributions to that project. So in terms of deploying the proxy, as I've already touched on, if you imagine a Cassandra node topology, you would deploy the proxy onto every node. And the reason for that is because when client drivers are making connections to any cluster, they will look for information from system.peers about the other nodes in the cluster, and then they will route the opening of channels to those nodes, to those IP addresses. So it's important for the proxy to be running on every node, and then the only application change that you need to do is just change the port. So that's literally, once you have the proxy installed on every Cassandra node, all the application has to do is communicate with a different port, and that's it. And then at that point, the proxy is going to route all requests, both reads and writes, to the nodes that it's running on, the source, whatever you define as the source cluster, and then it will asynchronously forward writes and updates to the target Cassandra system, whatever that happens to be. And then in terms of configuring the Spark, you can do this simplistically by just taking a simple sample that we have in the instructions online, as long as you backdate the write time. But in some cases, you might need to preserve the original write time. And the sample that I'm going to be using, as I mentioned before, is the Cassandra Migrator sample, which also handles that preserving and also has validation routines and retrying of failed records, as I said before. Okay, so what I have here is a resource group with an open source Apache Cassandra cluster deployed with 3 nodes. And I also have a Cassandra API account created with a key space, a table and a key space, which should have no data in there. And if I connect to my source Cassandra cluster here, I've already inserted 100,000 rows. That should, this is to simulate historic data that would already be in there. Of course, you have much larger volumes in a real scenario. And then I can also connect to my targets Cassandra accounts with the same tool, obviously. And if I select the count there, that should be 0. And so what I'm going to do now, in fact, before I do that, let me just also show you that I have the proxy, the DualRight Proxy installed on each node in my source Cassandra cluster here. So that's ready and waiting to accept connections, and then it will route writes and updates only to my Cassandra account. You can see here it's configured with a target with my Cassandra account host, and the sources on each node, the source IP address of each node. And so it will manage that routing when my client is connecting. So if I go to my app here, if I click enter here, what it's going to do is simulate updates to the existing data and inserts of new records to the source cluster, and then the proxy should be routing those requests to my target Cassandra API account. And so when I hit this and it starts doing the live updates, then I should see some activity in the proxy. So let me start this going here. And then if I go to my proxy here, you can see there it's already made connections. And so it's now routing requests. So if I go to my source CQLSH here, I should see the count starting to increase because there are new records coming in here, as well as the updates to existing records. And if I go to my Cassandra API account, I should see some records starting to come in. Of course, the number is not the same because I have not copied over my historic data yet. So while that's going, and this simulates a live scenario where you've configured the DualRight Proxy to handle live updates, I now want to copy my historic data. So I'm going to go to this Spark sample that we have, where I've got a historic data copy set of cells here. So let me just expand this guy here. This is just copied from the online sample that we've set up. So let me just minimize that. If I just go into here, and I'm just going to choose to run all of the cells above this. Let me expand that again. So what I should see here is this starting to run. Okay, and that's finished. Now that that's finished, I can also run my migration or validation routine as well. But before I do that, let me just go and check the counts, because there should be a difference there. Let's see where we're at with the source cluster, and now the target cluster should be much closer because the historic data has been copied over. But what I still need to check, as we talked about before with the pattern, is do the records match? Are there any inconsistencies? So I'm going to run this cell here to check that. Okay, that's finished, and let me just quickly run this cell here to see how many failures we got, if any. Now, there are failures there, but I'm going to tell you, I deliberately engineered the cause of this failure, and what's happened is that if I go to my proxy window here, you'll see here request rate is large, and this is by far the most common issue and challenge that we see customers facing when they're trying to move data or migrate data into Cassandra API, or any API for that matter, particularly if they're coming to one of the open source APIs and they're used to provisioning in a traditional way, is that they don't provision request units sufficiently, or they get caught out by rate limiting, which is, of course, what happens in Cosmos DB if you exceed the provision throughput. Cosmos DB, as many of you will know, operates on a request-based currency. You have to provision your workload in terms of requests per second, and each request has a cost. So if you exceed what you've provisioned, then you get this rate limiting. One way of avoiding that, of course, or there's a few ways of avoiding that or minimizing that or preventing that, is in Cassandra API. For those of you who don't know, I'm sure many of you do, we already have server-side retries capability. So to limit the effect of that, you can enable that feature on here. Also, of course, if you're running a data copy at the same time as a steady state workload that's happening, where live updates are happening, you might want to consider limiting the throughput if you're using a tool like Spark, which is what we recommend for its throughput capability. And by the way, Spark, this process that I'm using here, can also be used for offline migrations. If offline migrations are okay, then you probably want to use this process in exactly the same way. But here I'm using it alongside the DualRight Proxy to handle a live migration, because in this scenario, the customer wouldn't want any downtime. So as I said, if you want to limit the effect of rate limiting or eliminate it, you'd want to reduce the amount of throughput that's happening, or maybe you would just run the data copy during a quiet period where there aren't many updates, live updates coming into the system. So, okay, that's all very well. So now we know we have some failures in here, and I can see that my live system is still running. So what I want to do is I want to address those failures by retrying them. So we've got this sample here that allows you to do that. So let me just run this one as well. And what that will do is filter on the records that failed, and then attempt to reload only those records. Now, of course, I'm running this while the system is live running. To be really certain of getting data in sync, ideally, you want to take a little bit of downtime so that you can validate source and target and make sure they're completely in sync, and then cut over the application. But it is possible to do this validation while live running if not having any downtime is more important than the process of validation, maybe taking a little bit of data loss or correcting those on a ad hoc or piecemeal basis is preferred. So that's run. Let me see. You can see here my application is still running. It's still taking live updates. Let's see if when I run my validation here, I still get errors. Bear in mind, this is happening while live updates are coming in. So as I said, it might not be completely reliable while you've got live updates coming in. But let's see what we get here. All right, so that's finished. Now let's see how many failures we got here. Okay, so there's still failures. So like I said, the way to get this reliable is really to take some downtime. So let me simulate taking downtime by just stopping my application here. So let me go back and do the validation routine again. We'll do the retry routine again, because that will pick up failures and then attempt to reload them. Okay, so that's finished running. Let's see if we've still got failures now. We really shouldn't be getting any failures at this point. Okay, that's finished running. And we can see there's no failures there. And the one last check to do, of course, is to go to my source. Let's see how many records we have in the source. and we should have exactly the same number of records in the target. And at this point, you could just, yeah, there we go, they're both the same. And at this point, you could obviously just start the application running after you've cut over to point the application to the new target. And that's it for live migration to Cassandra API using the DualRight Proxy and the Spark connector with the samples that we have here for doing that. And just one last thing I do want to point out also, if I just go back to my app here, that when creating the target schema, the key space and tables, there are some extra flags that you have to set in Cassandra API. So that's really the important thing to note, because this whole process that I've shown really is exactly the same as if you were doing it for Cassandra Managed Instance. And there are some scenarios, as I've said, that you might need to do that if the source Cassandra cluster isn't compatible with what we support. Then you might need to take this approach. That the approach is really exactly the same, but with Cassandra API, you need to enable these flags, and this enables a feature that we call cell level TTL, which allows write time to be preserved, which is important when you're copying the historic data over during live updates coming through the DualRight Proxy, so that those records don't overwrite the live updates coming in, obviously. And so that's why this is important. And that's it for live migration to Cassandra API using this approach. Okay, so just finally, these are some links to resources that will help with everything that I've shown in this session. Of course, there are offline approaches as well. We still recommend Apache Spark, and using Databricks as a PaaS service for Spark is very useful. And Spark, really the reason we recommend it, or one of the main reasons we recommend it, is because of its ability to generate a lot of throughput. So if customer doesn't want to do a migration in real time, or doesn't need to, prefers to do it offline, but of course they need to do it quickly, or if they have a small window, then Spark really can generate a lot of throughput, certainly a lot more than the typical open source tools, SS Table Loader and so on. For doing an offline migration, we really do recommend that. And in the case of Cassandra API, it's really the only option, because you need an approach that is going to use the wire protocol rather than migrating from underlying files and so on, because of course the backend platform is not the same as Apache Cassandra. We are compliant with the wire protocol, but the backend system is of course CosmosDB. So that's really the only option there. And that's everything. Thank you.